Welcome to the second day of 4-day code camp on Hibernate and JPA and EJB and JMS. Today we are going to cover these four topics. We are going to cover Hibernate transaction and concurrency, and then Hibernate join fetch and infamous n+1 select problem, and Hibernate caching, and JPA basics. So those are four topics we plan to cover today. Tomorrow we are going to cover the rest of the JPA, and then the fourth day we are going to cover the rest of the topics in this 4-day code camp. All right, so let's start with JPA transaction presentation. So these are the set of topics we are going to cover. So we are going to first talk about session and transaction scopes, and then we will talk about transaction demarcation. So depending on what kind of transaction schemes do you use, you can use a different transaction demarcation. For our hands-on lab, we are going to mostly focus on JDBC-based exercise. And then we are going to talk about the locking. So here we are going to talk about mostly optimistic locking, and we are also trying to look into pessimistic locking as well. Session scope patterns. So a session is considered as a unit of work. Yesterday we talked about session as a container of persistent state object. Okay, so whenever you are committing or closing a session in some cases, you are going to flush all the persistent state object to the database. So you can consider that as a unit of work. So grouping data access operations. So all the database operations will be performed for the state object, persistent state objects contained in a session. So we refer to Hibernate session as a unit of work because the scope of session is exactly that. So basically, to begin a unit of work, you open a session, and to end a unit of work, you close a session. So session scope patterns could be one of these four patterns. Session per operation pattern, session per transaction pattern, and session per transaction with detached the object pattern, and session for long conversation pattern. And you can use any of these patterns. So let's talk about session per operation pattern. So in this pattern, a single Hibernate session has the same scope as a single database operation. So you are creating brand new session for each database operation, for example, like a save, and then you close after save it is done. And obviously this is strongly discouraged because the overhead for creating and closing, opening and closing a session for each database operation could be higher than that is needed. Session per transaction pattern, in this case, a single session has the same scope as a single database transaction. So within that transaction, you can in fact perform multiple database operations. For example, save the multiple objects, so a bunch of other database operations. So this is most common pattern for multi-user environments. So if you see the picture here, the session has a match to session and the transaction matches. Session per transaction with a detached the object pattern. So in this case, you have a session matches with the first transaction, and then there could be some detached the objects in between. And then we are going to start another session, which also actually matches the second transaction. The last pattern is a session for long conversation pattern. So here you have a session here, and then you could have in fact the multiple transactions, and you could also have some detached the objects in between. All right, so let's do our first exercise. So these session patterns, I mean, there is no rule that you have to follow. I mean, it's just the way that you are going to write your application. Okay, so let's do our first exercise 1. So we are going to play around with these patterns. Okay, so first we are going to try the first pattern. So this is the session scope where it matches with a single operation. Okay, this is for, so yeah, so this is basically reflecting what we have covered in the presentation. So in this case, let's try to run Hibernate session scope per operation. So let's run that guy, and session scope and the operation, and just run it. Main method, default package, okay. So the result is nothing fancy. I mean, we are going to just perform a single operation within a session. So this is what we are going to see. So if you take a look at the code, okay, so we have opened a session here. So we have a session, and then we perform transaction and commit. And for each of those, in each session, we are going to just perform one single database operation, in this case, save. Okay, and then for the second save operation, we actually creating the another session, and then again we close it. Okay, so this is the one session per operation pattern. Okay, obviously you can see overhead of actually opening and closing a session here. Okay, that the second pattern is session scope is per transaction. So in this case, we are going to perform two the lifecycle operation, save operations within a single session. Okay, and that session is also matches with the transaction. And the third pattern is we have a session, and then we have a detach the object in between. Okay, so if you take a look at this one, we have a session, and then we are going to perform some database operations, and then we close the session. So when we close the sessions, in this case, P1 and P2, person 1 and person 2 objects now become detached state. Okay, so this is something that we have seen yesterday, right? Okay, and then we create another session. Okay, and then we also create another transaction, and then we have we are going to merge that detach the object, and then we are going to perform operations. Okay, and so this is basically the pattern number 3 as we have seen here. Okay, so this is the pattern that we are using. Okay, and the 1.4 and 1.5, this is a case that we are going to use a single session, but we have a multiple transactions in between inside. Okay, so if you take a look at the code, we have a single session, and then we have a transaction, the first transaction, and we perform it and we commit it, and then we create another transaction, second transaction, so within the same session, right? Okay, and then we perform another lifecycle operation from that transaction. So this is the case that we have multiple transactions within a single session. Okay. Another way that you can have a long session is basically, in this case, we are going to disconnect the session. So basically, we are disconnecting the session, but session is, and then we are going to reconnect. Okay, so we still use the same session, but we have multiple transactions as well. Okay, so these are just the patterns, the way that you can actually write your code. Okay, and there is no concrete rule that you have to follow. Okay, but in general, we are going to use the second pattern most of the time, which is the session with matches with the transaction. Okay. All right, so I'm going to give you guys about the 7 or 8 minutes to try this exercise. Transaction demarcation. So we have seen this transaction demarcation code in our samples already, so this is really nothing new. So as we talked about, every single communication to the database is through transaction. Okay, so no communication with a database can occur outside of a database transaction. And all lifecycle operations, database operations, save and everything occur within a transaction. So always use clear transaction boundaries, even for read-only operations. So that is a must. Okay, Hibernate application running mode. So there are the two different ways that you can run your Hibernate application. One is non-managed, the other one is a managed. Okay, so I mean, same concept we're going to talk about in JPA later on. So non-managed is typically a standalone application or a simple web or swing application. The second type of Hibernate application is managed by container environment. Okay. So we've been actually working with the sample applications on non-managed mode. Okay, so non-managed environment, the application developer has to manually set transaction boundaries. So it's your responsibility to begin a transaction and then commit or rollback database transaction yourself. So that's the reason we're actually seeing begin and commit and rollback in our code, because we are basically dealing with non-managed environment. Okay. For managed environment, now this is some container is going to provide transaction boundaries. Okay, so you don't have to actually specify begin, commit, or rollback yourself. Instead, the container will actually use method call, starting of the method call as the begin of transaction and end of the method call as the commit or rollback. If there is an exception, it will roll back, and if there is no exception, it will do the commit. Okay, so in that case, in managed environment, is a container that handles the transactions. Okay, all right. And in this case, you are going to specify the transaction requirement declaratively. Again, this is the same for JPA. Okay, and so this is called the CMT, Container Managed Transaction, because it is the container's responsibility to begin and commit and roll back, not you. Okay. Okay, so portability of applications. So it is often desirable to keep your persistence layer portable between non-managed resource local environment and systems that rely on JTA but use BMT instead of CMT. So even in container environment, you could actually use BMT, meaning the beam managed transaction instead of CMT. So when you want to use a CMT, you have to use this transaction annotation. If you're not using transaction annotation, then even in container environment, it's your responsibility to start the transaction and commit and roll back the transaction. So these two environments, non-managed environment where you have to actually perform transaction yourself, or BMT environment, you still have to perform the transaction demarcation yourself. So we want to have the same code to be able to be used in these two environments, non-managed resource environment and BMT environment. Okay. So Hibernate offers these wrapper APIs. You can think of this one as a high-level API that translated into native transaction system of your deployment environment. So you are going to use this transaction, the API, which is going to translate it into this non-managed and also BMT environment. If you're using CMT, then you're going to just use the transaction attribute, so you don't have to actually be responsible for studying transaction or commit and rollback. Okay. All right. You can certainly use a low-level API if you want to. Okay, because this high-level transaction API is optional, but it is recommended because it provides the portability of your code. Ending a session actually involves these kind of things: flushing a session, commit or rollback, misspelled, rollback the transaction, and close a session and handle the exception. So this is the code that we have seen all along. So if you take a look at the code, this is again non-managed environment case that we've been seeing all along because we are using a Java SE application. Okay, so basically you have a session, and then you have to you are basically using transaction the API, and then we are going to get the transaction object, and then you do some work, and then you do commit. Okay. So you do not have to flush the session explicitly because the commit automatically triggers the synchronization depending on the flush mode of the session. Okay? And then the commit will roll back, and then at the end you're going to close the session. This is the managed environment, but you are using BMT, meaning it is still your responsibility to start the transaction, ending a transaction. Now, you can see this code is exactly the same as previous non-managed environment. So this is the portability of the code that we are talking about because you are using this transaction object. Okay. So exactly the same code. Manage the JTA environment, but the same code. Okay. So this is the so this is the case that you are using user transaction object, which is a bit lower level API. So this is the case that is not recommended in Hibernate case because so this one you cannot actually use in standalone Java SE application. Okay, so transaction API. So this is the portable API we just talked about. Okay. So the core of transaction in Hibernate is a transaction interface, and this interface is implemented to provide 3 of the built-in classes that do the real work. Okay, and again, the code that we have seen is basically you get the transaction object by calling begin transaction method from a session object. So underneath, these are 3 different types of transaction implementation. So JDBC, that is the non-managed environment, and the JTA transaction and CMT transaction. So JTA transaction and CMT transaction, this is the managed environment, and this is where you are going to actually use the declarative transaction, and then container is actually responsible for the begin and ending the transaction. And JTA transaction, you still have, this is still managed environment, but you still have to perform the beginning and ending transaction yourself. Okay. Regardless of these 3 different implementations, you are going to still use the same, or actually at least these 2, you are going to use a transaction object. Okay. All right, so the choice of transaction implementation class can be specified in your Hibernate CFG.xml file. So you can specify this. By the way, JDBC transaction is a default. So that's the reason you don't have to actually specify in Hibernate CFG.xml file in our sample applications. Okay, but you can add this this element in your Hibernate.cfg.xml file, explicitly indicating that you are using JDBC transaction. Okay, so that is a default. Okay, so method of transaction interface. Yeah, again, we have seen this method being used in our sample code: begin, commit, and rollback. Those are 3 methods that we have used, right? But you can also use other methods like is active or set timeout, transaction will timeout, it was committed, and was rolled back. All right, so exercise 2. So, exercise 2 is something that we have kind of worked with already, so nothing really new, okay? So the first exercise is a transaction API config. So we just want to actually see what is the transaction implementation class that we've been using. Okay, so if you take a look at the code, okay, so let's actually run that code first. Transaction API config, and I'll explain what that means. Transaction API config. Okay, so it just displays the what is a class implementation, transaction class implementation. So you can see this is a JDBC transaction implementation class. Okay, so let's take a look at the code. Okay, so we get the transaction object, right? And this transaction is interface. So if you want to actually get the class, actual implementation class, you're going to call the getClass method on that object that was returned from begin transaction. Okay, so basically, we see that is a JDBC as a default. Okay, so you can actually add this line if you want to. Okay, if you want to. Okay, so or you can just comment this out and you should actually see the same object being displayed, okay, because this is the default in our standalone non-managed environment. Okay. 2.2 is again we are playing around with the commit and rollback. Okay, so this is actually the same code that we have seen yesterday. So you can just kind of look at the code and then move forward. And this is the commit case, and this is rollback case. So when you roll back, nothing is being committed to the database. Okay, so that is the code. All right, so I'm going to give you 3 minutes for you guys to try this exercise too. Types of transaction demarcation. So the non-managed environment, transaction demarcation, yeah, we are going to actually look into different ways of actually transaction demarcation, non-managed and managed environment. Okay. So as we have seen before, transaction demarcation with a non-managed and transaction demarcation with the JTA BMT, they look the same. This one, transaction demarcation with the EJB and CMT, container managed environment. This is where you are going to use the transaction attribute, and it is the responsibility of the container that performs the transaction demarcation. And there could be also transaction interceptors, okay? But we're not going to actually talk about that. All right, so let's talk about transaction demarcation with the JDBC. So this is actually the sample code that we have seen before. Okay, so this is where you do not have a JTA support. Okay, so this is JDBC-based transaction demarcation is used mostly in standalone application. So here you can actually manage in 2 different ways. You can manage the session yourself, or you can let Hibernate manage the session. So when you manage the session yourself, basically this is the default setting that we have before, and then you are going to actually call open session from the session factory, and then you have to call the close yourself because you are managing the session yourself. Okay. So this is what we have done before. So basically from a session factory, then we open the session and we got the session and then we close. Okay, so this is a case that you manage the session. Okay. Now you can let the Hibernate to manage the session. Okay, in this case, you can actually call the get current session. So when it is called the first time, Hibernate will actually open the session for you. And when the transaction ends, meaning when the commit or rollback is done, then the session is closed automatically by the Hibernate. So in this case, you are letting Hibernate to close the session for you. Okay. When you call the get current session next time, it will actually create a new session as well. Okay. So creating a session and closing a session is done by Hibernate for you. Okay. So this is the code. You're basically get current session, and then you basically perform the operation, and then you don't have to actually close the session yourself. Okay. So when you commit a rollback, session will be automatically closed by Hibernate. Okay. So when you call the get current session the first time, the session will be created. In terms of configuration, this is the to enable thread-bound strategy in your Hibernate configuration. This is actually something that is in the standalone environment. You can actually have per thread based the session. Moving forward, transaction demarcation with the JTA. So JTA is basically when the transaction needs to be performed against multiple transaction resources, such as the database and message queue. I think there was a couple of questions. What happens when you do deal with multiple resources, multiple data bases? This is where you need to, in fact, have a JTA. The reason is because there has to be some kind of distributed transaction manager So, if you're dealing with, let's say, two resources, database 1 and database 2, and if you need to perform operations against those two resources in a transactional manner, then you have to actually have some kind of transactional manager, and that is actually provided by JTA. Okay. So JTA is actually supported in all Java EE app servers. Every Java EE app servers has a JTA support built in. Okay. So the data source used in such a container is automatically handled by the JTA transaction manager. So this is actually built in Java EE app servers. And JTA and Hibernate. So Hibernate automatically binds the current session to the current JTA transaction. So, I didn't actually kind of explain this one in detail. In the standalone environment, okay, the session is actually bind to a particular thread, okay. But in JTA environment, the session is bound to the current transaction, okay. So we're going to actually talk about this concept in a bit more detail when we talked about JPA later on, either at the end of the day, at the end of today or early tomorrow. So this enables easy implementation of session per request strategy with the get current session method of a session factory. And basically all you have to do is just the get current session, and then JTA transaction will be created for you. And every call, so as long as JTA transaction is still pending, every call to get current session will return the same session that's associated with the transaction. So in this case, the session has a one-to-one correspondent to transaction. Okay, so that is a case in JTA environment. However, in a standalone environment, if you have a multiple thread, and each thread will have actually the match to your transaction. Okay. Okay, so in this case, this is explicit transaction demarcation. We basically have a user transaction or transaction object, and then we begin, okay? And then you can actually do some work, like a load and persist and things like that. So Hibernate configuration. So basically, you have to actually, configure the JTA. Now, in general, you are going to use Hibernate along with, let's say, another framework, such as a Spring framework. Okay, so you rarely have to do configure Hibernate transaction, the JTA like this yourself. Instead, you are going to actually use a Spring framework JTA configuration. Okay, so if you take a look at the Spring database topic in the Spring framework course in jpassion.com, you will see, in fact, the examples where we are actually setting this JTA through Spring framework rather than Hibernate. Okay. All right, so transaction demarcation with CMT. So this is the case that you are using container managed transaction using attributes. So in this case, instead of actually coding begin, commit, and rollback yourself, you are actually asking the container to do the transaction demarcation. Okay, so basically you are going to use you're going to use this annotation. So transaction attribute and transaction attribute that required. Okay. So when you specify this, and that means, you're asking the container to perform the transaction begin and commit and rollback. Okay. Again, we are going to actually have the bunch of exercises when we do JPA. So this is exactly the same JPA. It's exactly the same annotation you are going to use in JPA as well. So we're going to do some exercises later on when we do JPA. All right, so exercise 3. So here we're going to just mostly do standalone Java SE transaction demarcation. So basically, we are going to try, you manage this session and Hibernate manage session. Okay, so in this case, the result is pretty much the same. So let's actually run this guy. So you manage the session, run as an application, and and then Hibernate. The result is going to be the same, but we are going to see the code with a slight difference. Okay. All right, so let's take a look at the code. This is the case that you manage the session. So in this case, you are going to open the session yourself, okay? And you have to close the session, okay? Because you manage the session yourself. Now, the second case is you are asking Hibernate to manage the session. So in this case, instead of actually calling open session, you are going to call get current session. So when you call the get current session, if there has not been any session per this thread, it will actually create one for you. Okay. Later on, you don't have to close the session. In fact, if you enable this guy, you will have an exception because it's already closed. Okay, so the configuration here is this is a case that we are actually asking Hibernate to manage the session. Okay, so let's try the exercise 3, and we are going to uncomment the code and see whether we in fact receive some exception. Okay, so this is the one that I'm going to uncomment. Okay. Oops. I want to just uncomment these 3 lines. Okay, and let's run this code. And as you can see, we have experienced session was already closed exception. Okay. All right, so I'm going to give you guys about the 10 minutes to try this exercise. So optimistic locking or optimistic concurrency control. Sorry. So what is the optimistic concurrency control or optimistic locking? It's an approach. It's actually, in fact, default approach for most environments, in which an item is locked only during the time it is accessed in the persistence mechanism. I'm going to actually show you a picture in the following slide, so you will actually have a better understanding. So example is that if a customer object is edited, a log is placed on during the time it takes to read. So it's going to actually read it, lock it and read it, and then it will unlock it. Then when once it added it, it will actually be committed. It will be saved, right? And at that point, it will try to lock it again. And then if it is successful, it will write it and then unlock it, okay? The problem of this approach, however, is that, between the time that you read and between the time that you write, it's possible that somebody else actually change that record, that row of the table. In that case, there is actually a race condition. Okay, so in that case, the Hibernate will cause an exception. So let me show the picture. So this is the yeah. So I want to actually show the picture, and I'll be back. Okay. So this is, suppose you want to change a table. If suppose you want to change a record, meaning a row of the table. What you want to do is you're going to read that record. Okay, so you're going to lock it when you read it. Okay, so you get the result. Okay, that's fine. And then you're going to unlock it. Okay, so somebody else could actually change at that point. So you're going to work with the data. So you're going to actually change it. Okay, and then you are going to, when you are ready to write, you are going to lock it again. Okay, and if nobody changed it, then there shouldn't be a problem. So you should be able to change it. However, if somebody already changed, okay, between the time that you read and before you are going to write your change, then that is actually a problem, right? So in that case, Hibernate would say, there is a problem, okay? That there is a collision. So it will cause an exception for you, and you have to handle it, okay? This is actually used in most of the environment because optimistic locking is based on the assumption that most database operations are mostly read, and most database transactions do not conflict each other. So basically it will provide much better performance. because multiple clients should be able to access the table concurrently. Okay. And this is actually used when the conflicts are rare, meaning many reads and occasional write. That is the typical database usage pattern in most environments. So that is why optimistic locking is used, mainly for better performance. Okay. All right. So let's so how do you actually implement the optimistic locking? Basically, in your table, you have to have a version column. And so every time a particular record is changed, the version column number gets incremented. Okay. So whenever you commit, it will be incremented by 1. So, if you actually go back to this case, you are going to read the data. So that version number, let's say it is 2 at that point, okay? So if nobody changed it, then when you actually commit the change, then it will be changed to 3. So that's perfectly fine. But when you read number 2, but somebody changed it, that means the version number incremented to 3. Now, when you're trying to write your own change, you can check the version number in the table is mismatching with what you expect. You expect the version number is supposed to stay in 2, but somehow it's changed to 3 because somebody else actually changed it. So that's where the Hibernate actually detect the collision, and it will cause an exception. Okay. So that is how things are working here. So version checking uses the version numbers or timestamps to detect the collision updates. And here we are going to use a version number. Hibernate provides several possible approaches for writing application code that uses the optimistic concurrency. So application version checking, automatic versioning, and customizable automatic versioning. And we are going to just use the default scheme, okay, of the having a version. Oh, let's actually see the code. So this is the configuration. So you are going to say optimistic lock version, and then you have to have a column called the version and type of int. Okay, so that table has to have a version. So basically you have so 2 things. You have to have a table that contains the version column, and you also have to specify optimistic lock version. Okay, and then Hibernate will actually use the version number of this column to perform optimistic locking. Pessimistic concurrency locking is that you are going to actually lock the whole thing. So if you actually go back to our previous case, when you need to change, you are going to lock the whole thing here. Okay, so you're not going to unlock. You're going to lock it, read it, and you change it. And then once you change it, you're going to lock it. Obviously, this is going to actually have much worse performance compared to optimistic locking because it's basically serialized locking. Okay, so if there are multiple users trying to change data on the table, then every single client has to wait somebody else's to finish the change, meaning the period of locking is a lot larger in pessimistic locking. So that's the reason pessimistic locking is not being used often, because again, most of the database usage pattern is many read and occasional write. However, if your database usage pattern is small number of read but frequent update or write, then pessimistic locking is probably preferred. Because if you try to use the optimistic locking, then you have to do a lot of the exception handling, and that could actually cause more overhead. Right? So depending on your application, the application's database usage pattern, you can choose either optimistic locking or pessimistic locking. All right, so that is actually how pessimistic locking works. Okay, so when to use, so basically pessimistic locking is ideal for batch jobs that need to ensure consistency in the data that they write. So in this case, we are talking about many writes, right? Better than any small number of read possibly. All right, so let's do exercise 4. So in exercise 4, the first exercise is optimistic locking. So here what we are going to do is we are going to simulate 2 different users, multi-user test user 1 and multi-user test number 2. Okay. And first of all, we are going to actually see the version number gets incremented. So, let's run this guy first. Every time you actually make a change, commit a change, you are going to see the version number gets incremented. Okay, so if you see the code, you basically commit to change 3 times, and each time the version number gets incremented. Okay, and you also have to have again optimistic lock equal the attribute of optimistic lock to version, and you have to have a version column. Okay, and your person table also has to have this version field, of course. Okay, all right, so let's actually run that application. And optimistic locking and version, observe version number. So just run it. Okay, so you can see the final version number is 3, right? And every time you make a change, the version number gets incremented. So starting from 0, 1, 2, 3, and 4. So make a change, make another change somewhere in your code. Okay. So for example, in main, make another commitment and see whether that gets incremented. Okay. All right, so that is the first exercise. The second exercise, we are going to simulate the 2 different users trying to access the same record, and we are going to experience optimistic locking. So you can actually try the non case. Okay, so this is a case we do not use the optimistic locking, and then it will actually override the change that somebody else actually created. Okay, so you can try this one first, and obviously this is not desired situation, so we are going to actually experience optimistic locking. So let me actually run the code first. So here, this is the first user, and main. So it actually make a couple of changes, and then it's going to display this code. Okay, so this is the option dialog. So this application is asking you to enter your name. Okay, so this is actually trying to change a particular record. Okay, now we are going to run this guy, the second guy. Okay, so we are basically reflecting we are simulating the second user change the record while the first user has read it and about to change. So let's run this guy. So now this guy is going to run the application. So second user is running, and it will change the record. Okay, so it changed the record. The version number is changed 4. Now, if I try to change, so I'm going to just add whatever name of your choice. And now first user is trying to write back. Now it's trying to commit. Okay. It expects the version number is supposed to be still 3. But as you can see, the version number, as you saw, the version number has been changed to 4 by the second user. So now if I try to run it, then we are going to experience the optimistic locking error. Okay. Yeah, so this is the optimistic locking that we just, so row was updated. Yeah, so this is the state object state exception. This is the optimistic locking exception. Row was updated and deleted by another transaction. Okay. All right, so that is the exercise for that one. So let me just explain the code. So this is the so basically run the first user, and then before you enter anything, you're gonna actually run the user number 2. So user number 2 is changed to 4. Now you're gonna enter data and okay, and then you're going to experience this. Okay. So if you take a look at the code, you're basically changing, and here we are going to use a J option pane. We read first, right? We read the record first, and then we are going to use the J option pane. Okay. And then we are going to actually have a second user to change it. Okay. And then you're going to see what happened. This is a pessimistic case. This one, because the first user is completely locked, right? There should not be any exception. However, again, this is going to cause the bad performance. Okay, so let's try pessimistic locking. So pessimistic locking user 1. What is pessimistic? The second user, which one is supposed to? So this is user 1, and okay, so looks like what we want to do is we are going to run this guy first. This is a pessimistic locking, and all right. So this guy completely locked. So if I try to run the second user, right, it will not be able to run it. Okay. So let's see what happens. Yeah, it's just waiting because the first user has not released it. Okay, so now if I run the first user, I'm going to just say okay. Now if I actually go back here, this guy now is got the lock and we're able to actually change it. Okay, so that's a pessimistic locking, meaning the first user hold the lock for the whole time. Okay. All right, so I'm gonna give you guys the 15 minutes to try this exercise.